In this question, we're given data in the form of a graph and in the form of a table of values from two different containers. And this data represents the volume of water in the containers over time. We notice that the volume of water is decreasing in both cases. Therefore, water is draining out of the containers. And what we have to determine is which container is the volume of water draining at the fastest rate. Another key piece of information is that the water is draining at constant rate. That means that the relationship is linear. And what we want to look at is the slope of both of these representations. So the word constant means that it's going to be linear, and the word rate means that we're going to be looking at the slope. Okay, so let's start by looking at the slope of container A, the line for container A. To find the slope, we need a couple of points. So the first point would be this point right here, the initial value, which is 60 liters. And as we move down the line here, we want to find another point that's fairly straightforward to calculate. So it might be this point here. So at 2 minutes, we'll have 35 liters of liquid. And then another point that we might want to use is this one right here, which means at 4 minutes, there will be 10 liters of liquid. So let's try the slope between this point here and this point here. And we know that slope m is equal to the rise over the run. So if we start here, then in this case it's not, we're actually going down, so that would be 10, 20, 25. So the rise in this case would be minus 25 because we're going down. And the run here would be from 2 over to 3, 4 would be 2. So this would equal negative 12.5. In this case, the rate would be liters per minute. So the container is draining at 12.5 liters every minute. Now we could verify to make sure we got the right answer. For example, we could go from 60 here, liters, down to here, which is 35 liters, and look at the rise and the run again. So it would be from here, would be down 10, 25, and over 1, 2. So we would get the exact same answer. Could also go from 60 here down to 10 liters, and we can see that the difference is 50 liters, and it's over 1, 2, 3, 4. So 50 divided by 4 would also give us the 12.5 liters per minute as the rate of change. All right, let's take a look now at container B, the table of values. And again here, slope in this case would be rise over the run, or another way to think of it is the change in volume, liters, over the change in time, which is minutes. So if we look at the change here in liters, from 54 to 32 is equal to 22 liters. And from 1 to 3 minutes would be a change of minus 2 minutes. So that would give us a slope or a rate of change of minus 11 liters per minute. Again, we could verify to make sure. So if we looked at between 32 and 10, that would be a change of 22 liters. And again, from 3 to 5 would be a change of minus 2 minutes. So that would give us a negative 11 liters per minute again. And we could also do it between 54 and 10 and 1 and 3, and we'd still get the same rate. It is a constant rate. So if we compare these two rates, we can see that container A is draining at the fastest rate. So we'll circle container A. To justify our answer, let's graph the second container. All right, let me get rid of this these lines here to make it a little bit easier to see. Okay, at time 1, there was 50. At 1 minute, there's 54 liters in container B. So we go from 1 all the way up to 54, which is about here. And we stick a point there, and then we continue to look at time 3. There was 32 liters, so if we go to time 3, go up to 32 is about here. And finally, for time 5 minutes, there's 10 liters, so we go to 5 and go to 10 liters right there. And we can draw a line through these points as best we can. And when we do that, we can compare the slopes of each of these lines, and we can see that container A, represented by this line, has a steeper slope than container B. Therefore, container A must be draining faster because the slope of container A is steeper. In other words, since the slope of the line of container A is steeper, therefore it is draining faster. And there you go.